Look at this mountain in central Iran. From the outside, just rock, bare desert, nothing. But beneath it, Iran hid one of the most sophisticated nuclear facilities ever built, buried 80 to 90 meters underground inside solid granite behind reinforced concrete walls. The world's most powerful bunker buster bomb, the GBU-57, can penetrate about 60 meters of reinforced concrete. Fordow sits deeper than that. Iran didn't just build a nuclear facility. They built an underground city, tunnels, centrifuges, command centers, missile halls, a parallel civilization carved beneath the earth, estimated to have cost over $20 billion. And the question the world is asking right now, as bombs fall on Iran, did any of it reach what's buried down there? Today, we go inside the impossible bunker. Everything starts here, the Iranian Plateau, a landlocked fortress of mountains and desert, perfectly designed for hiding things underground. For over 4 decades, Iran has been building a nuclear program, first openly, then secretly, and eventually deep underground. Natanz, Iran's main enrichment site, sits 40 to 50 meters below the surface, and that was just the beginning. The logic is simple. Put it above ground and it can be bombed. Put it underground and the math changes in your favor. From the outside, the Fordow mountain looks completely unremarkable. Bare rock, desert terrain, no signs of life. But at the base of that mountain, 2 tunnel portals, blast doors, and the entrance to one of the most fortified structures ever built. Fordow sits 80 to 90 meters underground, the equivalent of burying it beneath a 25-story building made of solid granite. Once inside, a vehicle-capable tunnel leads deep into the mountain, wide enough for trucks, reinforced against collapse. The mountain itself is the first layer of defense, 80 to 90 meters of granite absorbing blast energy before it reaches anything critical. Then comes reinforced concrete, multiple thick layers added during construction to harden the facility further. Inside the underground halls, rows of centrifuges. Fordow was designed to hold approximately 3,000 centrifuges across 2 main enrichment halls. Each centrifuge is a precision machine, a spinning rotor that separates uranium isotopes by using centrifugal force. Feed uranium hexafluoride gas into the centrifuge, spin it fast enough, and lighter U-235 concentrates at the center. That's enrichment. Connect 164 centrifuges in a cascade, and each stage multiplies the enrichment level, building toward weapons-grade material step by step. To keep it all running, a facility this size needs enormous power, transformers, generators, and backup systems, all buried alongside the centrifuges. Ventilation is another hidden engineering challenge, maintaining breathable air for workers and stable temperature for machines, deep inside a sealed mountain. Cooling systems prevent the centrifuges from overheating, piped water and heat exchangers, all engineered for permanent underground operation. And Fordow is only one node. Across Iran, underground missile bases, officially called missile cities, exist in every single province. Inside these missile tunnels, ballistic missiles on mobile launchers, stored in rows inside tunnels 6 to 10 meters high and 6 meters wide. The launchers can drive out through tunnel exits, fire and return underground, fire and hide, making them nearly impossible to permanently destroy. This isn't localized. It's a national underground military infrastructure spanning the entire country, designed to survive any air campaign. Meanwhile, even Natanz went deeper. Satellite analysis revealed new tunnel construction reaching 80 to 100 meters, matching or exceeding Fordow's depth. These facilities are found from space by analyzing subtle clues, Earth excavation debris, heat signatures, and vehicle movement patterns. The construction itself is a massive logistics operation. Tunneling machines, rock conveyors, and months of heavy machinery work before a single centrifuge goes in. The blast doors alone are an engineering achievement. Multi-ton steel structures designed to withstand the overpressure wave from a nearby surface explosion. Fordow is built near Qom, one of Iran's most sacred cities. Placing it there adds political sensitivity to any strike targeting it. Construction reportedly began in secret as early as 2002, continued for years without international knowledge, and was discovered by US, UK, and French intelligence in 2009. Satellite analysts noticed unusual excavation debris and vehicle patterns near an unremarkable mountain, the first hint that something enormous was being built underneath. In September 2009, US President Obama, French President Sarkozy, and British Prime Minister Brown simultaneously revealed the existence of Fordow to the world. Archives later revealed the facility was originally designed for weapons-grade uranium production, not just civilian enrichment. Fast forward to February 2026, just days before the US-Israel strikes, satellite imagery showed Iran pouring fresh concrete shields at Parchin, racing to harden even more. Iran knew strikes were coming and spent the final weeks burying everything that could be buried, a desperate race against time and air power. The weapon designed to reach these facilities is the GBU-57 massive ordnance penetrator, 6.2 meters long, weighing over 13,000 kilograms, the largest conventional bomb ever built. Only one aircraft can carry it, the B-2 Spirit stealth bomber, which can fly undetected to any target on Earth. A B-2 strike mission from Diego Garcia to Iran covers thousands of miles, multiple aerial refueling stops, extreme crew endurance, precision navigation. The GBU-57 is released, GPS-guided fins adjust its trajectory, and it impacts the target at maximum penetrating velocity. Maximum confirmed penetration for the GBU-57, approximately 60 meters of reinforced concrete. Fordow sits at 80 to 90 meters. The gap is real. The tactic to compensate: drop multiple bombs in the same spot sequentially, each one drilling deeper into the crater left by the previous hit. Every generation of Iranian underground facilities goes deeper, Natanz at 40 to 50 meters, Fordow at 80 to 90, new Natanz tunnels reportedly reaching 80 to 100 meters. Iran is already reported to be building new facilities deeper than Fordow, designed specifically to be unreachable by current bunker-busting technology. Rock type matters. Fordow's mountain is granite, which is harder than the concrete the GBU-57 was designed to penetrate, making it even more resilient. The most successful attack on Iran's nuclear program wasn't a bomb. It was a line of code. Stuxnet, a cyber weapon, destroyed approximately 1,000 centrifuges at Natanz between 2009 and 2010. A piece of software did more damage than any bomb had managed, by targeting the centrifuge control systems directly, making them self-destruct. Iran's response to Stuxnet: rebuild faster, with more advanced centrifuges, and move even more of the program underground. Iran was enriching uranium to 60% purity before the 2025 strikes. 90% is weapons grade, making it technically only one step away from a bomb-ready material. That 60% enrichment level was itself a deliberate provocation, close enough to weapons' capability to be threatening, not close enough to be a clear red line. IAEA inspectors had been monitoring Iran's facilities, but Iran had progressively restricted access, reducing transparency in the years before the strikes. In June 2025, the U.S. launched its first strikes against 3 Iranian nuclear sites, Natanz, Fordow, and Isfahan, in a coordinated multi-wave campaign. Over 125 U.S. aircraft participated in the operation, including B-2 bombers, carrier aircraft, electronic warfare planes, and tankers. The damage assessment became immediately politicized. The White House claimed all 3 sites were obliterated. CIA assessments suggested core components likely survived at 2 of the 3 sites. Natanz, at 40 to 50 meters, appears to have been severely damaged, with above-ground structures demolished and underground sections collapsed. Fordow, at 80 to 90 meters, showed no visible surface damage in satellite imagery immediately after strikes. The mountain looks exactly as it did before. The engineering reality. With current technology, Fordow's depth provides a genuine structural advantage. No bomb currently deployed has a confirmed ability to reach its core. Isfahan sustained partial damage to above-ground components, but underground sections remain unassessed with certainty. Iran's immediate response after the 2025 strikes began tunneling new facilities at even greater depths, confirming the cycle of attack and deeper rebuild. Just before the March 2026 strikes, satellite imagery caught Iran adding reinforced concrete shields at Parchin, trying to buy minutes of additional protection. The pattern is now clear. Every strike triggers deeper construction, making the problem not smaller but harder over time. The March 2026 U.S.-Israel strikes represent a second major campaign targeting ballistic missile infrastructure alongside nuclear sites. One tactic used, targeting the tunnel entrance portals directly, attempting to seal the facility and deny access rather than reach the deep chambers. A blast at the tunnel entrance sends a shockwave inward, but at 80 to 90 meters, the rock absorbs most of the energy before it reaches the critical halls. CSIS 2026 analysis concluded, strikes can inflict significant damage and significant delays, but cannot permanently eliminate the program through force alone. Deep underground, command centers coordinated Iran's response, protected from the strikes above, maintaining operational continuity. Iran has spent decades developing the internal engineering expertise to build these facilities. That knowledge cannot be destroyed by airstrikes. Below the surface, fuel reserves, food stores, and independent infrastructure mean these facilities can operate for months even if surface access is cut off. Think of it as an underground nation. Enrichment, missiles, command, power, water, and workforce, all beneath the earth, all connected. The Irg Aerospace Force, Iran's elite missile arm, operates almost entirely from these underground complexes, dispersed, protected, and ready to fire. Drone arsenals are stored underground too, rows of Shahd-type drones, ready for deployment through the same tunnel networks. Iran's strategy combines 2 advantages: the cost asymmetry of cheap weapons in volume and the physical protection of depth, making both offense and defense formidable. Even the water supply underground is engineered. Borehole wells and piped systems ensure the facility can survive surface blockades for extended periods. Electromagnetic hardening adds another layer, shielding against EMP weapons that might otherwise disable electronics without reaching the physical structure. The nuclear program is now so deeply embedded in Iran's national identity and military doctrine that even complete regime change might not end it. In 2018, Israeli intelligence reportedly stole 55,000 pages of Iranian nuclear weapons documents from a Tehran warehouse, revealing the full scope of the weapons design program. Before the 2025 strikes, experts estimated Iran's breakout time from decision to first nuclear device, at weeks to a few months. After the 2025 strikes, CSIS assessed that timeline was extended, but not indefinitely. The knowledge, the people, and dispersed materials remain. You can bomb centrifuges. You cannot bomb the engineers who designed them. Iran has trained thousands of nuclear scientists over 4 decades. Historical precedent. After Israel bombed Iraq's Osirak reactor in 1981, Iraq went underground, dispersed its program, and accelerated, nearly reaching a bomb by 1991. North Korea presents the same lesson. Its deepest facilities are estimated over 100 meters underground, operational and expanding despite decades of sanctions and pressure. The fundamental limit of force. You can delay, degrade, and destroy equipment, but you cannot erase the knowledge, the will, or the people behind the program. Iran's nuclear program is estimated to have cost over $100 billion in total, a significant portion going directly to underground construction and hardening infrastructure. Western sanctions slowed but did not stop the construction. Specialized tunneling equipment was obtained through intermediaries and domestic production. Inside the deeper sections of these complexes, living quarters for workers, medical facilities, and everything needed for months of self-sufficient operations. Thousands of workers, engineers, construction crews, specialized tunnel technicians, spent years of their lives building what no one was supposed to see. Whatever the politics, the engineering achievement of building this network is genuinely extraordinary. Decades of precision work, hidden from the world beneath mountains. Which brings us to the fundamental strategic question. How do you stop something you cannot reach? The answer most experts now agree on. No single tool works alone. Cyber attack, physical strikes, and intelligence operations together can degrade, but not permanently stop. Human intelligence, people on the ground inside the program, has historically been one of the most effective tools, responsible for discoveries like Fordow itself. Diplomacy once achieved what force could not. The JCPOA in 2015 converted Fordow from an enrichment site to a research facility, centrifuges removed, cameras installed. Then in 2018, the US withdrew from the JCPOA, and within months, Iran restarted enrichment at Fordow, reinstalled centrifuges, and resumed its program. After 2018, Iran accelerated. Advanced IR-6 centrifuges replaced outdated models, enrichment reached 60%, and underground expansion resumed at pace. As of March 2026, active strikes are ongoing. Natanz is destroyed. Fordow's deep core status remains uncertain, and new tunneling is reportedly already underway. CSIS assessment. Iran can rebuild meaningful enrichment capability in 1 to 2 years. The technical barrier to reconstruction is low for a program this established. The enriched uranium stockpile is arguably the hardest target, dispersed to multiple underground locations, potentially surviving any surface or shallow strike. Before the 2025 strikes, Iran reportedly dispersed its uranium hexafluoride cylinders to multiple underground storage locations, a standard dispersal strategy. Centrifuges themselves are fragile. The spinning rotors can be destroyed by shock waves even from a relatively distant explosion, but replaceable in 12 to 18 months. The full picture: Fordow, Natanz deep tunnels, Parchin military complex, missile cities in every province, drone storage tunnels, and underground command centers. One integrated underground nation. Each GBU-57 costs approximately $14 million, and multiple bombs may be needed per target. The tunnels cost far less to rebuild than the bombs cost to deliver. The economics favor the defender. Tunneling is cheap, bombs are expensive, and the physics of depth is permanently on Iran's side. That's the engineering principle at work. Protection does not scale linearly with depth. Each additional 10 meters underground provides exponentially more survivability. The next generation of bunker busters is already in development, longer, heavier, deeper. But Iran's response will simply be to build deeper still. The complete journey: a mountain in the desert, 2 tunnel portals, vehicle tunnels, blast doors, enrichment halls, centrifuges, spinning right now, possibly. One underground facility, Fordow, changed the entire strategic calculation of US-Iran relations, international law, and the global nuclear order for 2 decades. At golden hour, the mountain looks almost beautiful: bare rock, long shadows, desert light. Nothing tells you what's buried inside. We know it's there. We know the depth. We know the centrifuges were there. What we cannot know with certainty is exactly what survived and what was rebuilt. The next facility is already being dug, deeper this time, in a location not yet identified, under a mountain that looks just as unremarkable as Fordow once did. Bombs can go 60 meters. The facility sits at 80 to 90. Physics does not negotiate. Somewhere below Iran's mountains, desert, and cities, tunnels and machines and decades of work sit waiting. The surface world cannot reach them today. In 10 years, will those tunnels still be there? In 20, the engineering was built to last longer than any political agreement, any military campaign, any administration. The scale of what Iran built underground, regardless of purpose, is one of the most ambitious construction projects in the modern history of the Middle East. The title is not an exaggeration. At current known technology, Fordow is a bunker no bomb can reliably reach. The physics backs that statement. 4 numbers define this story: 80 meters deep, 3,000 centrifuges, $100 billion spent, 60-meter bomb limit. The gap is 20 meters and it changed history. The question that outlasts every bomb and every sanction: can diplomacy reach what force cannot? History has shown it can, and also shown how quickly that can collapse. The mountain at sunrise: ordinary, silent, golden. Knowing what's inside makes it one of the most consequential pieces of real estate on Earth. From orbit, you cannot tell. Just desert, mountains, and a country that built an impossible city underground and made the whole world wonder if anyone could reach it.